It has been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
After the James Webb telescope revealed what NASA was concealing on Mercury, the United States promptly shut it down. This little planet is anything but normal as it comes close to our enormous Sunday. Its fiery terrain is dotted with surprising gems, like diamonds, that glitter. However, beneath the shimmer is an odd and massive core that defies all prior understanding in science. What undiscovered tales lie behind these astounding discoveries? Join us as we reveal the discoveries that have the potential to completely change our understanding of the planets. Mercury may appear little when compared to the Sun, but don't be deceived by its size. Below that scalding surface is a treasure mine of amazing mysteries. Recently, a startling discovery was made by earthly probes. Diamonds are widely scattered over Mercury's surface. On one of our solar system's hottest worlds, diamonds. And that's only a cursory examination. As we dig farther, we discover that Mercury has a strange and remarkably enormous core. These findings raise an important question: what distinguishes Mercury from its planetary siblings, and what other mysterious stories may it be hiding? Since Mariner 10 was the first spacecraft to reach Mercury, it was a pioneer. It returned the first close-up images, revealing a world resembling our moon in terms of craters and odd ridges. This mission disproved long-held beliefs about Mercury's composition by revealing that the planet has a rough surface, an unexpectedly strong magnetic field, and a larger core than previously believed. However, that wasn't the most unexpected aspect. 31 years later, the Messenger mission began, revolutionizing our knowledge of Mercury. Messenger, in contrast to Mariner 10, was built to circle Mercury, enabling it to conduct extensive, long-term research on the planet. It took roughly 200,000 pictures, expanding our understanding of this fascinating planet and revealing hitherto unseen areas of Mercury. A fascinating discovery made by the Messenger mission was the observation of very high calcium and magnesium concentrations on Mercury's darker side. Scientists became interested in the possible natural mechanisms that produced these elements at such high concentrations as a result. It was also discovered that, in contrast to other planets in our solar system, Mercury's magnetic field was surprisingly greater in its northern parts. These discoveries made scientists recognize that their preconceived notions about Mercury's interior composition and evolution were greatly off. On Earth, the flow of molten iron within the core is often responsible for creating magnetic fields. However, Mercury exhibits a distinct kind of magnetic activity due to its distinct interior structure. What else distinguishes the scenery of Mercury? The planet is characterized by harsh weather in addition to its craters and ridges. Mercury's surface may get as hot as 806 degrees Fahrenheit during the day, which is hot enough to melt lead. However, the temperature drops significantly to around -292 degrees Fahrenheit at night. Mercury's tiny atmosphere makes little contribution to heat retention or temperature regulation, which results in this extreme temperature variation. But there are other unexpected aspects of Mercury besides its intense heat. Some surprising traits on its surface have been revealed by more recent investigations. Data from Messenger in 2012 revealed evidence of historical explosive eruptions as well as signals of volcanic activity. The old theory that Mercury was geologically dormant was called into question by this discovery. Then, in 2020, scientists made an even more fascinating discovery. Parts of Mercury's permanently shadowed polar craters were revealed to contain water ice. Despite Mercury's near proximity to the Sun, these places remain sufficiently cold to maintain frozen water. They are always protected from the Sun. There were increasing doubts regarding Mercury's capacity to maintain primitive life forms because of the ice. Could life exist in these frozen areas on Mercury, akin to those of Earth's most hostile environments? This query raises intriguing prospects for our knowledge of the possible survival of life on various planetary environments. But the narrative doesn't end there. Together with the Japan Aerospace Exploration Agency, the European Space Agency launched the Bepi-Colombo spacecraft towards Mercury in 2018. By 2025, it is expected to reach Mercury. As it arrives, Bepi-Colombo will begin gathering comprehensive data about the planet, including its surface composition and geological past. Interestingly, Mercury has some water ice and a strong magnetic field despite being so near to the Sun. What may surprise you even more is that Mercury has a day that is longer than its year. Typically, when we think about planets, we picture them around the Sun once a year and rotating on their axis once every day. Mercury, though, is not like that. A day is actually longer than a year on this little, sweltering planet. Come with me as we investigate Mercury, where a day is longer than a year. A symphony of sun and shadow. Mercury's year is far shorter than ours. It only takes 88 Earth days for it to complete one orbit around the Sun. On the other hand, a whole day on Mercury, or a full rotation on its axis, takes around 176 Earth days. Therefore, on Mercury, a year is just half as long as a day. This has some rather peculiar results. The Sun rises and gradually grows larger as it travels across the sky, as seen from Mercury. However, an odd occurrence would occur. The Sun would seem to come to a stop, retrace its steps, and then carry on. Because Mercury spins so slowly in relation to how quickly it circles the Sun, it causes this peculiar movement. The oddest part, though, is not that. First of all, why does Mercury revolve so slowly? Tidal locking holds the key to the solution. The gravitational pull of the Sun has been steadily slowing Mercury's rotation for billions of years. Mercury is in a 3:2 spin orbit resonance, in contrast to the Moon, which is completely locked to Earth. This indicates that Mercury spins 3 times for every 2 orbits around the Sun. Mercury experiences harsh circumstances as a result of these peculiar orbiting and spinning patterns, particularly given its peculiar day-night cycle. Mercury's solar-facing side experiences months of intense heat, while its solar escape side has equally lengthy periods of icy darkness. Some of the solar system's most extreme temperature swings result from this. It's crucial to remember that Mercury doesn't actually have what we would consider a proper atmosphere while discussing it. Rather, it possesses a very thin layer known as the exosphere. Due to its extreme sparsity, this layer continually evaporates into space and is only sporadically replenished by solar wind, radioactive material disintegration, and collisions from small space pebbles. Unexpected information on Mercury's exosphere has been revealed by recent research. 2020 data from the Messenger spacecraft showed that scientists had previously underestimated the amount of water vapor in Mercury's exosphere. This water vapor is probably created when oxygen in the rocks on Mercury's surface combines with hydrogen from the solar wind. The speed at which Mercury circles the Sun, in contrast to its comparatively sluggish revolution on its axis, is another amazing feature of the planet. Its magnetic characteristics are affected by this peculiar mix. Scientists were surprised to learn that Mercury possesses a strong magnetic field despite its modest size and sluggish rotation. Subsequent research indicates that Mercury's specific spin and orbit combine with special internal motions within its liquid metallic core to produce this magnetic field. Even so, it is significant that this magnetic field is less than Earth's. Mercury's surface is shielded from the strong solar wind by it. Mercury's already thin atmosphere would be further thinned by the solar wind in the absence of this screen. Mercury spins slowly, which makes for some fascinating scenarios when paired with its rapid orbit around the Sun. Mercury has areas on its surface known as hot poles, where the Sun appears to pause in the sky for a period of time, resulting in extraordinarily heated conditions there. However, due to persistent darkness in the regions close to Mercury's poles, ice may survive despite the planet's close proximity to the Sun. Mercury's distinct spin and orbit around the Sun are the reason of this. Even though the rest of the globe is scorching hot, the craters in these dark regions remain very cold because they never get sunlight. Researchers are also questioning whether there are any additional materials, possibly even organic ones, hiding in these frigid areas. Mercury's slow rotation and quick orbit have an impact on our understanding of the planet. It is a difficult target for spacecraft because of its rapid orbit around the Sun. Spacecraft must employ sophisticated navigational procedures, including many flybys of Venus and Mercury, in order to slow down sufficiently to enter orbit around Mercury. These flybys are now being used by the Bepi-Colombo mission to modify its trajectory and speed. After 9 flybys, Bepi-Colombo, which was launched in 2018, is anticipated to begin circling Mercury by 2025. Once there, Mercury's peculiar day-night cycle will present difficulties that must be overcome by careful control over its power and temperature in order for it to live. The mysteries of Mercury begin to surface as one digs deeper. An odyssey into the heart of the planet, however, there are other difficulties. According to recent research, Mercury may have formerly spun more quickly but gradually slowed down as a result of the Sun's gravity and potential impacts with other celestial bodies. This discovery not only sheds further light on Mercury's past, but also on the processes that shape the planets in our solar system as they evolve. New inquiries concerning the inside and surface of Mercury arise as we learn more. Its core, which appears somewhat fluid in spite of the frigid temperatures, and the way its peculiar orbit influences its geological aspects, piqued the interest of scientists. The scientific community is always intrigued by the new findings and what more they may uncover about Mercury. Mercury continues to astound scientists and cast doubt on our understanding of the formation and evolution of planets. What additional mysteries may be concealed beneath the surface of this little planet full with craters? Mercury is the smallest planet in our solar system, yet scientists are still baffled by a number of its secrets. Despite its little size, it has several rather strange characteristics. Mercury's enormous core is among its most intriguing features. According to a research headed by planetary scientist Dr. Nancy Chabot, Mercury's core comprises around 85% of the planet's entire volume. In comparison, just 15% of Earth's bulk is comprised of its core. This begs the important question, why is Mercury's core so massive? One widely held belief is that Mercury was once considerably larger, but that, during a massive collision early in the solar system's history, it lost much of its outer layers. This notion was put out by Dr. Eric Asfog and is referred to as the hit-and-run scenario. He proposed that Mercury may have been struck by a massive object that stripped away its outer layers and left behind the iron-rich core that is seen today. Mercury continues to amaze people, nevertheless. Scientists were surprised to find a magnetic field on this tiny, slowly spinning planet. With a magnetic field that is around 1% as powerful as Earth's, Mercury possesses a worldwide magnetic field, unlike Venus and Mars. Scientists were baffled by this finding, which NASA's Messenger spacecraft made. Then there was still another turn. Mercury has an uneven magnetic field, according to research by Dr. Katherine Johnson and her colleagues. In actuality, the planet's radius is displaced by around 20%. Variations in Mercury's crust may be related to this odd change, since they may have an impact on the planet's core's ability to release heat. And if that wasn't enough, scientists discovered in 2020 that volatile substances like sulfur, potassium, and sodium are present on Mercury's surface. This further enigmatizes a planet that is already complicated, provoking further inquiries and research as researchers attempt to solve Mercury's numerous puzzles. However, these findings just hint to what Mercury may still be concealing. What more may this little planet disclose? It is remarkable to see some compounds on a planet thus near to the Sun that normally vaporize at high temperatures. An intriguing concept has been proposed by Dr. Patrick Peplowski of the Johns Hopkins Applied Physics Laboratory. He speculates that these materials, which transform into gas very fast, may have been carried to Mercury by comets or asteroids much later on in the formation of the planet. The discovery that water ice exists inside permanently shadowed craters at Mercury's poles is among the planet's most thrilling discoveries. As we previously noted, Dr. Nancy Chabot was instrumental in this research. Because the craters are too cold to receive any heat from the sun, these icy areas remain frozen. The finding of biological stuff in these frozen areas is even more intriguing. Researchers have discovered dark regions that could hold complex carbon molecules, which are comparable to those that may have contributed to the origin of life on Earth. Is it possible that Mercury, with its harsh environment, might provide us with information on how life first emerged in our solar system? When it comes to its geological activities, Mercury has other surprises. Scientists believed Mercury to be geologically dormant for a very long period. However, fresh data from the Messenger spacecraft suggested recent volcanic activity. On the surface of Mercury, what appear to be tiny, lustrous volcanic vents were discovered by Dr. David Rothery of the Open University in the UK. These structures, known as hollows, provide insight into the planet's continuing geological processes. Next, the landscape of Mercury is a maze of mystery and disorder. Mercury's chaotic heart, the chaotic landscape, a vast, disorganized region of hills and valleys close to the southern pole, is one of the planet's most perplexing geological characteristics. This area, roughly the size of Texas, was found during the 1970s Mariner 10 mission. According to Dr. Thomas Waters of the Smithsonian Institution, this terrain may have been formed by large earthquakes that were triggered by the Sun's gravitational pull when Mercury's orbit altered. That's not all, though. We now have a better knowledge of Mercury's internal structure thanks to recent research. Mercury's interior composition was examined by Dr. Amir Khan of the University of Zurich using information from the Messenger mission. According to his findings, Mercury has a solid inner core and a liquid outer core, just like Earth. Mercury's inner core, however, is far bigger in comparison, which might account for some of the planet's peculiar magnetic characteristics. These unexpected characteristics of Mercury force us to reconsider the formation and evolution of planets. They serve as a reminder that there are still a ton of undiscovered things, even in our own backyard, the immensity of space. We can only speculate as to what additional fascinating information could be concealed beneath Mercury's surface as we eagerly await more investigations and discoveries. Mercury's secrets are just as fascinating as anything that can be seen on its surface, as evidenced by recent missions and research. The inside structure of Mercury is really amazing. Mercury has a mainly liquid core with a solid center, in contrast to Earth, which has a solid inner core encircled by a liquid outer core. NASA's Messenger mission, which investigated Mercury's gravity to find out more about the planet's interior, verified this. About half of Mercury's total core is made up of its solid center, which is around 1,260 miles, 2,000 kilometers, broad. Only 20% of the Earth's core is composed of solid matter. This distinction in composition and size is significant since it contributes to the formation of Mercury's magnetic field. Mercury is a tiny planet, yet despite this, it nevertheless has a rather powerful magnetic field compared to Earth. The mantle layer is remarkably thin, sitting just above Mercury's core. Compared to Earth's mantle, which is estimated to be 1,800 miles, 2,900 kilometers, deep, scientists now believe that this mantle is just 260 miles, 420 kilometers, thick. The distribution of heat on Mercury and its geological activity are influenced by this thin mantle. However, Mercury is more complex than first appears. The Messenger mission found evidence of historical volcanic activity on Mercury in 2012. It's possible that Mercury contained more volatile compounds than previously believed since the probe discovered unusual, shallow depressions known as hollows, which were created when volatile molecules near the surface evaporated. Then, in 2020, researchers discovered evidence of a sizable magma reservoir that had formerly existed beneath Mercury's surface using information from Messenger. The planet's surface and deeper layers were probably significantly shaped by this ancient sea of magma. Mercury's surface features large, flat plains, particularly in the northern hemisphere, which can be explained by this magma sea. Known as the Northern Volcanic Plains, these regions were probably formed early in Mercury's history by massive lava flows. Mercury surprised us again, though. Researchers found even more mysteries under Mercury's stony surface in 2022, demonstrating to us that there are still a lot of untold stories about this planet. Researchers examining messenger mission data have discovered indications of nitrogen subterranean on Mercury. This nitrogen may represent remnants of a dense, prehistoric atmosphere driven underground by the extreme heat and continuous solar radiation of the planet. This finding raises intriguing queries concerning Mercury's history. Was it formerly considerably thicker in atmosphere? What does this indicate about the circumstances that existed on the planet in the past, and is it possible that life was maintained there? In the shadowy craters near Mercury's poles is aqueous ice as well. This ice is on the surface, yet the intense cold in these shaded places keeps it shielded from the sun's rays. According to recent studies, part of this ice may be quite recent, having most likely been delivered in the last few tens of millions of years by comets or asteroids. There are indications now that Mercury is still evolving, revealing geological mysteries, but that's not all. It's also believed that biological stuff, probably carried there by the same space impacts, is present in these dark areas within the polar craters. This organic substance presents a unique chance to examine the distribution of organic molecules in the inner solar system since it is less stable than water ice. The underlying characteristics of Mercury also reveal information about its geological past. Mercury does not exhibit plate tectonics as Earth does, but it does exhibit distinct evidence of contracting as it cooled. The many thrust faults that crisscross its surface, where certain sections of the crust are forced upward over others to occasionally reach heights of several kilometers, are indicative of this. These flaws provide important insights on Mercury's interior composition and geological past. The fascinating part comes next. Additional investigation into these faults raises the possibility that Mercury is still geologically active. A 2019 study discovered evidence of grabens, which are tiny valleys formed by crustal straining close to some of the planet's biggest faults. Given their apparent youth, these characteristics suggest that Mercury's crust is currently undergoing change. Moreover, Mercury has a magnetic field that is distinct from Earth's. Mercury's magnetic field most likely originates from a different mechanism than that of Earth, which raises more questions regarding how magnetic fields are created on other planets. Earth's magnetic field is created by molten iron flowing in its outer core. The theory that Mercury's magnetic field is created by liquid metal circling the planet's solid inner core is now being investigated by scientists. This mechanism suggests that Mercury has an incredibly active and complicated interior, akin to what we observe in other planets and stars. However, there's more. Subterranean Mercury is a topic of great interest to scientists. It is their belief that the planet's crust may include numerous fractures and cracks. These could make it possible for heat and possibly even liquids to travel between the planet's layers. This theory is especially fascinating since it implies that Mercury, which was previously believed to be geologically dead, may yet have some active processes occurring within. Despite the fact that Mercury's surface is now dry and arid, some scientists believe that there may be water pockets concealed far below the crust. If these reservoirs of water are real, they may represent the remains of a period when Mercury experienced a more mild environment, or the planet's internal heat may be keeping the water liquid. This theory is consistent with discoveries made on moons like Europa and Enceladus, which conceal seas behind dense ice sheets, raising questions about potential locations for life in our solar system. The discovery of water on Mercury may inspire more investigation into the planet's historical ecology and capacity to sustain the chemical reactions necessary for life. Should water be discovered, it might provide crucial information about the planet's geological past and pose fresh queries regarding the chemical processes taking place under the surface. But Mercury isn't the only factor in this. Scientists can learn more about the formation process of rocky planets like Earth by investigating its innards. Comprehending the volcanic activity, Earth's core composition, and Mercury's geological past are essential to constructing a comprehensive picture of the solar system's planet's evolutionary history. Each new finding about Mercury broadens our understanding and provides new perspectives on the early solar system. For example, Researching gases and other materials buried beneath Mercury's surface may provide important insights on the planet's prehistoric atmosphere and environmental circumstances that prevailed billions of years ago. There is increasing anticipation for upcoming expeditions to Mercury. These missions will investigate Mercury's surface and its undiscovered depths using cutting-edge technologies. We want to discover more about this enigmatic planet and its role in the greater scheme of our solar system with every expedition. Mercury is tiny and near the Sun, but it still has a lot of secrets. Not only might exploring its depths help us learn more about Mercury, but it may also hold the key to understanding the formation and evolution of our solar system. Studying Mercury is crucial to the area of planetary research and exploration because it provides a rare chance to comprehend how the Sun affects the planets. What findings may put our existing knowledge of the solar system to the test? Minutes ago, the shocking information that NASA concealed about Mercury was just revealed by the James Webb Telescope, and it is rather damaging. This little planet, situated just next to the scorching Sun, harbors startling mysteries. Imagine finding glistening riches on the planet that you least expect. Furthermore, unlike everything else in our solar system, the core of Mercury remains a vast enigma from which several researchers have received unusual signals. What horrible secrets may Mercury be keeping hidden? Let's explore the bizarre realities that Mercury is attempting to conceal. Not far from the Sun, the little planet Mercury has been keeping some intriguing secrets. For a long while, despite its enormous size and intense heat, we understood very little about its true nature. However, subsequent space missions have revealed some unexpected findings. For example, experts think that this hot planet may contain diamonds. That's not all, though. Its inside is peculiar. It's bigger and weirder than you may think. What distinguishes it from planets that are nearby? What mysteries are concealed behind its exterior? The most recent findings are set to be made public, but nobody anticipated that the information would spread so swiftly. Astronomers and space enthusiasts have always been captivated by the tiniest planet in our solar system. Its landscape remained a mystery to the naked eye for a very long time. We didn't begin to learn its mysteries until after we made advancements in space technology. The first spacecraft to visit it was Mariner 10, which provided us with our first in-depth look at this tiny planet. It captured images of a surface like our moon, complete with odd ridges and craters, as it flew near. This mission disproved previous theories about the planet's structure by revealing a rough, crater-filled surface, an unexpectedly strong magnetic field, and a larger-than-expected core. Unlike its predecessor, Mariner 10, which only stopped by for a short while, the Messenger spacecraft orbited the planet for a considerable amount of time. This made it possible for it to investigate the planet in more detail. Messenger's mission yielded an astounding 200,000 photos, revealing areas that had before been inaccessible to the human eye. One specific discovery stuck out among the many others. The darker side had remarkably high quantities of calcium and magnesium. Numerous questions concerning the geological processes that could result in such an anomaly were raised by this discovery. It was also noted to have an unusually potent magnetic field, which was especially noticeable in its northern areas. This is not a feature found on any other planet in our solar system. This variety of findings challenged pre-existing hypotheses and planetary science while also deepening our grasp of the subject. Scientists have to reconsider their theories on its formation and construction in light of these facts. Most planets, like Earth, have magnetic fields created by the movement of molten iron in their cores. However, the distinct internal structure results in distinct magnetic behaviors. However, it's not only craters and an odd magnetic field. Extreme surface conditions exist. Temperatures throughout the day can get as high as 806 degrees Fahrenheit, hot enough to melt lead. At night, however, temperatures drop dramatically, creating a sharp contrast with the daytime heat. It is far from simple, as evidenced by the other recent discoveries and the extreme temperature changes. It continues to be a subject of curiosity and inquiry, appending our preconceived notions about planets. The Mercury can plummet to an extremely cold -292 degrees Fahrenheit here. Its extremely thin atmosphere, which does nothing to regulate temperature or retain heat, is the source of this. Even with these harsh circumstances, recent studies have revealed some amazing surface features. Data from the Messenger spacecraft in 2012 revealed evidence of past volcanic activity, raising the possibility that the region may not be as geologically calm as previously believed. Scientists found evidence of explosive volcanic eruptions, which means it has been more active in the past than we imagined. Next, in 2020, scientists discovered a startling new finding: water ice patches in crater ice near the poles. These craters are in areas that never see sunlight, making them cold enough to keep ice frozen, an amazing find for a planet so close to the sun. This has raised concerns about the possibility of life in these frozen areas, particularly microscopic life forms that are able to withstand harsh environments. Let's investigate a planet that has its own laws, starting with the day and year that are particular to it. A day lengthier than a year, the European Space Agency and the Japan Aerospace Exploration Agency launched Bepi Colombo, their most recent mission, in 2018. It is scheduled to arrive there in 2025 with the goal of acquiring more in-depth data on the surface, composition, and geological past of the planet. There are yet more surprises in store for it, such as the finding of water ice and an unexpectedly powerful magnetic field. It also has a peculiar fact: despite its close proximity to the sun, its year is shorter than its day. How on earth could that be? Normally, we think of planets spinning around once each day and orbiting the sun once each year. However, it's not the same. Its year is far shorter than ours, taking only 88 Earth days to complete one orbit around the sun. However, a single spin on its axis takes 176 Earth days. This indicates that a day there is equivalent to twice a year. And that's not even the most peculiar aspect. If you were standing on it, you'd see some really odd things. The sun would appear to halt abruptly after rising and enlarging in the sky. It might even begin to travel in reverse for a little while before eventually making its way across the sky again. Its sluggish spin can't keep up with its quick orbit around the sun, which causes this unusual movement. Why is its rotation speed so slow? The reason for this is a phenomenon known as tidal locking, which is the result of billions of years of the sun's intense gravitational attraction. However, unlike our moon, which is fully locked with Earth, it is only partially synchronized with its orbit. This causes its strange spin pattern, where its days are so much longer than its years. Its spin locks it in a special position, unlike Earth, where one side is constantly facing Earth. For every 2 orbits around the sun, it completes 3 spins. On its surface, this peculiar pattern, referred to as a 3:2 spin orbit resonance, creates a very harsh environment. Because of this pattern, one side always faces the sun and gets quite hot, while the other side is left in the dark, getting very chilly. This causes some of the solar system's most extreme temperature shifts. There is hardly any atmosphere on Mercury. It's so thin, in fact, that scientists refer to it as an exosphere. The gases that make up this exosphere are constantly escaping into space. Things like the solar wind, the decay of radioactive materials, and small meteorites striking the surface take their place. There are some unexpected discoveries regarding the exosphere made by a recent study. For instance, data from the Messenger mission in 2020 revealed very high water vapor levels. Researchers believe that the reaction between oxygen in the surface minerals and hydrogen from the solar wind produces this water vapor. Its magnetic field has peculiar effects due to its rapid orbit and sluggish spin. It possesses a worldwide magnetic field despite its small size and sluggish spin, which is thought to be caused by a special process in its liquid metal core. The peculiar orbit and rotation have an impact on this process. The magnetic field is nevertheless very important, even if it is weaker than Earth's. It shields Earth from the ferocious solar wind. Without this magnetic barrier, the solar wind would soon take away what little atmosphere there. It also produces some amazing vistas with the way it spins and orbits. Certain regions of the surface, referred to as hot poles, experience extreme heat when the sun appears to pause in the sky. However, in some areas close to the poles, it never becomes light and is permanently dark. Remarkably, water ice has been discovered by scientists in these shaded regions. Next, we learn more about the frozen surprises that lurk under this planet's surface. Exploring the hidden craters, but this isn't the oddest part. This ice remains frozen because the craters are shielded from the sun's rays, which keeps them extremely cold even in the sweltering heat of the surrounding areas. Scientists are now questioning if any additional materials, possibly even organic compounds, might be concealed in these chilly, gloomy areas in light of this unexpected discovery. It's difficult to send spacecraft to Mercury. Because it revolves around the sun so quickly, these missions require meticulous preparation. Before a spacecraft can slow down sufficiently to reach orbit, it frequently needs to pass by Venus and Mercury many times. It takes some deft maneuvering to meet the problems presented by the fast speed across space. With the help of other planets' gravity, the BepiColombo spacecraft is presently traveling toward Mercury, gradually changing its direction and speed. The spacecraft was launched in 2018 and is scheduled to begin circling Mercury in 2025, following 9 flybys of other planets. When BepiColombo gets to Mercury, it will have a difficult time adjusting to the odd day-night cycle. The spaceship has to balance maintaining system functionality during the long, frigid nights with limiting the amount of heat it absorbs from the sun. Achieving this balance is essential to the mission, particularly given the challenging circumstances brought on by the peculiar orbit and spin around the sun. Recently, new computer models have shed light on how quickly Mercury is rotating. According to these simulations, it may have once rotated considerably more quickly, but impacts from space objects like asteroids and comets as well as the sun's gravitational influence caused it to slow down. This information helps us understand Mercury's past and gives clues about how other planets in our solar system developed over time. But that's not all. New questions come up when scientists study Mercury in greater detail. They are interested in how its peculiar orbit affects its surface and how its core remains partially molten despite the long, frigid nights. These queries highlight the vast amount of knowledge that remains concerning our own solar system. The distinctive characteristics stretch the boundaries of our scientific beliefs and encourage us to consider novel concepts as they relate to the formation and evolution of planets. And under its cratered surface, maybe, lie even more surprises. Mercury is the smallest planet in our solar system, yet despite this, it is brimming with interesting features. It never ceases to astound scientists with its distinct characteristics and surprising findings. The unusually massive core of Mercury is one of the most intriguing discoveries. According to a research conducted by planetary scientist Dr. Nancy Chabot of the Johns Hopkins Applied Physics Laboratory, the core of the object takes up around 85% of its entire volume. Compared to the Earth's core, which makes up only 15% of the planet's volume, this is far larger. However, why does it possess such a large core? One theory is that it was once a much larger planet that was mostly destroyed in a massive collision early in the solar system's existence. Dr. Eric Asfog of the University of Arizona has named this idea the hit-and-run scenario. It postulates that it may have been struck by a massive object that removed much of its crust and mantle, leaving behind the iron-rich core that exists today. However, this was hardly the only surprising discovery. Its magnetic field is also very strong. Its global magnetic field is around 1% that of Earth, whereas that of Venus and Mars is absent. The little planet's already fascinating nature is further complicated by its magnetic field. We now learn some startling facts about its surface and magnetic field. The odd mysteries of Mercury's magnetic field. Mercury has a magnetic field that is exactly as powerful as Earth's, according to a startling finding uncovered by NASA's Messenger spacecraft. This surprised scientists because they didn't think the small, slowly spinning planet could maintain a magnetic field. Scientists led by Dr. Katherine Johnson of the University of British Columbia discovered that the planet's magnetic field isn't centered in the center. Rather, it has been moved by around 20% of the planet's radius. They speculate that this could be because of the irregular thickness of the crust, which alters the planet's internal heat flow. Sulfur, potassium, and sodium were discovered by scientists on its surface in 2020. These substances would ordinarily burn up rapidly at high temperatures near the sun. So it came as a huge surprise to find them. According to Dr. Patrick Peplowski of the Johns Hopkins Applied Physics Laboratory, these elements may have been created by impacts from comets or asteroids that struck the planet after it had already formed. However, this wasn't the most unexpected finding. Researchers have also discovered water ice in craters close to Mercury's poles. Because these craters are always shaded and receive no sunshine, they are extremely chilly. This maintains the ice's frozen state. This ice was discovered by a team that included Dr. Nancy Chabot. It is an amazing discovery for a planet this near to the sun. There's more. These craters also included traces of organic molecules, according to researchers. Complex carbon-based compounds, such as those found in these dark deposits, may have contributed to the emergence of life on Earth. This implies that the planet may have information on the origins of life in our solar system, despite its harsh surroundings. The surprises, however, didn't end there. Scientists were surprised to see traces of geological activity associated with it. There was proof of recent volcanic activity discovered by the Messenger mission. Small, bright patches on the surface that appear to be volcanic vents were observed by Dr. David Rothery of the Open University in the UK, indicating that the planet is continually changing. Its chaotic terrain is a vast region, roughly the size of Texas, with jumbled hills and valleys close to the South Pole. Dr. Thomas Waters of the Smithsonian Institution says experts believe that powerful earthquakes brought on by the sun's gravitational pull during its orbital changes may have generated this. Many unsolved mysteries remain regarding this small planet so near to the sun. What more may we discover? Some intriguing insights regarding what's under the surface have been uncovered by recent investigations. Using information from NASA's Messenger mission, Dr. Amir Khan of the University of Zurich has conducted a deeper examination of its interior layers. Its study team discovered that it has a solid inner core and a liquid outer core, just like Earth. Nonetheless, compared to Earth, a far bigger portion of its overall size is made up of a solid core, which may account for some of the strange magnetic characteristics. These findings cast doubt on our understanding of the formation and evolution of planets. There's still so much to learn, even about our own solar system. We can only speculate as to what additional surprising characteristics could be lurking beneath its cratered surface as we wait for further space missions to offer more information. Missions underway continue to demonstrate that its inside is every bit as interesting as its outside. A significant discovery concerns the composition of the planet's core. Its core is primarily liquid with a solid portion in the center, unlike Earth, which has a solid core surrounded by a liquid outer core. The Messenger mission's observations of minute variations in the structure's gravitational field provided confirmation of its singularity. As we go deeper, we look at this tiny yet fascinating planet's peculiar structure and past. A somber investigation beneath the surface, however, this wasn't the most unexpected aspect. Roughly half of the overall size of the core is made up of the solid part, which is believed to be 1,260 miles broad. Compared to Earth's solid core, which makes up only 20% of the planet's core volume, this is far bigger. To create its magnetic field, its core's dimensions and properties are essential. This planet's magnetic field is unusually powerful for its size, even if it is weaker than Earth's. Regarding its structure, there is yet much to discover. Scientists now estimate that the mantle of the planet is only 260 miles deep, far thinner than previously believed. In comparison, the thickness of the Earth's mantle is around 1,800 miles. This significant difference influences the planet's heat-trapping ability and surface behavior. An intriguing finding regarding its hidden layers was found in 2012. Messenger discovered evidence of prehistoric volcanic activity in the form of shallow pits known as hollows. These hollows were probably created when specific substances vanished from the planet's crust, indicating that the planet may have once contained more of these volatile materials than previously believed. In 2020, researchers looking through Messenger's data uncovered yet another startling finding. Beneath its surface, they discovered indications of a large, old magma lake. This ancient magma sea might have played a key role in shaping its landscape and interior structure. Some of its distinctive surface characteristics, such as the broad, smooth areas that make up a substantial portion of its northern section, may also be explained by this ancient magma sea. Known as the Northern Volcanic Plains, these areas are thought to have developed from massive lava flows that happened at an early point in the region's history. However, that wasn't the most unexpected discovery. Scientists deduced another mystery from Messenger data in 2022, indications of nitrogen below the surface. This finding raised the possibility that the nitrogen was driven underground by the extreme heat and sun radiation of the planet's early atmosphere. Its past is interestingly called into doubt by this concealed nitrogen. Was its atmosphere thicker once? And if it did, what does it reveal about its primordial climate and the likelihood that it was livable at one time? The finding of water ice in craters at its poles raises yet another intriguing puzzle about its secret layers. Even though these craters are so near to the sun, the ice remains frozen because they are always under darkness. Some of this ice could be relatively young, deposited by comets or asteroids in the last few tens of millions of years. Additionally, there are dark deposits that experts think could contain organic molecules. These materials, which are more vaporous than the ice, may be debris from comets or asteroids that collided with it. These organic compounds provide a unique chance to investigate the distribution of these chemicals in the inner solar system. Could these organic molecules suggest prior life? Could Mercury contain diamonds? The most recent image obtained by the James Webb Telescope has completely altered our preconceived notions. It demonstrated to us that even an unassuming planet like Mercury may be hiding a wealth of information, much like diamonds could be found in its craters. This incredible discovery, made directly under the sun, showed us that our equipment was perfect. What startling mysteries may Mercury be concealing? Let's explore these pressing mysteries in more detail. An incredible deep space discovery. The initial image that we obtained from Mercury's orbit was breathtaking. It was exactly what we had hoped to see as soon as it popped up on the screen. We realized then that we had really succeeded and that everything was operating as it should have. Just now, NASA made public an amazing finding from deep space that was located on the little planet. Despite its unassuming exterior and near proximity to the sun, it conceals some intriguing and maybe lucrative mysteries below, such as diamond-containing craters. But when we zoomed in, the room became quiet. There, in the shadow of a crater, stood an obviously man-made building, a secret that Mercury was never intended to harbor. This little planet, which formerly appeared like just a feint through our telescopes, has become a source of astonishment. With the help of cutting-edge equipment from the James Webb Telescope and other missions, we've started to unearth some incredible discoveries. Recent research implies there might be diamonds deep within the searing environment. That's not all, though. Because of the very huge and peculiar core, scientists are having to reconsider their theories about the composition of planets. For many years, the landscape's secrets remained mostly unknown, but modern technologies have begun to reveal them. A significant step toward planet exploration was taken by NASA with the Mariner 10 mission in 1973 and the Messenger mission in 2004. Messenger captured detailed images of a surface replete with craters and odd ridges that resembled our moon while it was in orbit. These photos revealed a crater-filled, dense planet with an unexpectedly strong magnetic field and a bigger core than previously thought, which caused scientists to reevaluate their theories about the planet. A considerably sharper image of the planet was provided by the Messenger probe, which was meant to circle 31 years after the Mariner 10 mission. It remained in orbit, collecting an enormous amount of data and taking more than 200,000 pictures, revealing previously unseen areas. The highest concentrations of calcium and magnesium on the darker side were among the most intriguing discoveries. Scientists are still unsure of how these elements got there in light of this revelation. Although the circulation of liquid iron in the Earth's core produces magnetic fields, the distinct interior structure produces distinct magnetic characteristics. While nighttime lows might approach minus 300 degrees Fahrenheit, daytime highs can reach 800 degrees Fahrenheit, hot enough to melt lead. This large temperature change happens because the thin atmosphere cannot hold onto heat. Recent research has revealed several unexpected surface traits, even in spite of these harsh circumstances. In 2012, data from the Messenger mission showed volcanic activity, including hints of explosive eruptions, defying the conventional notion that the planet was geologically dead. Researchers declared that they had discovered water ice in a few of the Arctic craters. Despite the planet's close proximity to the Sun, the ice remains frozen due to the extreme coldness of these craters. Even more intriguing questions are brought up by this discovery, such as the possibility of simple life existing on the planet despite its hostile environment. Could there be life there? Although it may seem improbable, many types of life on Earth are able to endure the harshest environments conceivable. Therefore, even in its coldest and iciest places, it's not completely out of the question that anything may reside there. The European Space Agency and the Japan Aerospace Exploration Agency launched the Bepi-Colombo mission in 2018, and it is currently traveling toward the planet. With the arrival of this spacecraft in 25 years, we will be able to examine the surface, composition, and geological past in greater detail. However, the planet continues to astound scientists. You wouldn't anticipate a planet this near to the Sun to have features like a strong magnetic field and even signs of aqueous ice. The way time is handled there is even more bizarre. Unlike Earth, where we have clear days and years, the spin and orbit form a highly unique pattern. Did you know, for example, that a year is shorter than a day? Let's investigate what makes this planet so fascinating, its distinct day and year. Planets typically circle the Sun once a year and rotate on their axis once every day. Their secrets are revealed. But it defies these accepted guidelines. The year of an Earth is very short. It takes only 88 Earth days to complete one orbit around the Sun. One complete revolution takes 176 Earth days at the same time. That means that a day is twice as long as a year. If you were standing on the surface, these odd events would result from this strange time pattern. Imagine witnessing the Sun rise, grow larger in the sky, pause, retrace its steps, and then resume its course. This occurs as a result of the slow spin's inability to keep up with the Sun's rapid orbit. However, this is not the only peculiar aspect of it. The sluggish spin is supposed to be caused by tidal locking. This is a gravitational impact from the Sun that has slowed down the rotation over billions of years. It rotates 3 times for every 2 orbits around the Sun, in contrast to our Moon, which is perfectly locked in sync with Earth's rotation. This phenomenon is known as a 3-to-2 spin-orbit resonance. That doesn't mean the odd conduct stops either. The planet is subject to harsh circumstances due to its distinct day-night cycle. For an extended period, one side is exposed to the Sun and becomes quite hot, while the other side remains in the dark and remains frigid for an equal amount of time. It also has an extremely thin atmosphere, known as the exosphere, which is continually lost to space and then regenerated by radioactive decay, the solar wind, and small impacts from meteors. That's not the worst of it, though. In 2020, scientists were astonished to find much more water vapor in the exosphere than they had predicted. This water vapor is most likely the result of interactions between oxygen in the stony surface and hydrogen from the solar wind. The long days and short years also have an unexpected influence on the magnetic field. It's a small planet with a sluggish spin, yet surprisingly, scientists discovered that it has a magnetic field. According to recent research, the unusual orbit and rotation may be influencing a unique process known as the dynamo effect within the liquid metal core, which produces this magnetic field. This reduced magnetic field is nonetheless vital because it helps shelter the planet from the solar wind, which would otherwise take away its thin atmosphere much quicker. Still, Mercury's quick orbit and sluggish spin generate some genuinely unusual circumstances on the surface. For instance, the hottest areas on Earth are found in regions known as hot poles, where the sun appears to freeze in place in the sky. In the freezing, dark zones near the planet's poles, where sunlight never reaches, scientists have detected water ice. It's odd to discover ice on a planet so near to the sun, yet it exists due to the peculiar spin. Some craters near the poles are always in the shadow, making them exceedingly frigid. With the sweltering heat in other regions of the Earth, these ice craters stand in sharp contrast. Scientists are curious about whether other materials, such as organic compounds, might be concealed in these icy regions after discovering ice. But researching the planet is no simple undertaking because it circles the sun so swiftly. Major obstacles for space missions arise from this quick orbit and extremely lengthy days. 2018 saw the launch of the Bepi-Colombo mission, which is presently traveling toward the planet. It modifies its course by harnessing the gravity of Venus and Mercury. After 9 flybys, it is predicted to arrive in 25 minutes. However, the severe day-night cycle of the planet must be addressed by the expedition. When the spaceship is in the sun, it will experience extreme heat, therefore it must save energy for the long, chilly nights. These extremes demonstrate how difficult it is to investigate a planet like Mercury and test the boundaries of current technology. Next, we find out why this planet rotates so slowly and what it tells us about its past. Getting ready for the hidden threat research into the planet's sluggish rotation has recently been conducted. It appears that it was slowed down by the gravity of the sun and impacts with massive objects like asteroids, although it may have originally spun far more quickly. This helps us comprehend how planets in our solar system evolve over time and provides scientists with fresh information about the planet's past. The massive iron core of the planet, which makes up over 85% of its volume, is another thing that fascinates scientists. Compared to the Earth's core, which makes up only 15% of the planet, this is far bigger. Certain researchers believe it was previously a much larger planet, including Dr. Eric Asfog from the University of Arizona and Dr. Nancy Chabot from the Johns Hopkins Applied Physics Laboratory. They think that following a significant collision early in the solar system's existence, it lost the majority of its outer layers. However, this was hardly the most shocking discovery. Even though it's a tiny planet with a moderate spin, the planet nevertheless possesses a magnetic field. NASA's Messenger mission made the startling discovery that its magnetic field is only 1% as strong as Earth's. This discovery calls into question our understanding of magnetic fields on smaller planets. The University of British Columbia's Dr. Katherine Johnson, a planetary scientist, and her colleagues are now investigating this to find out more about the planet's peculiarities. These findings are causing scientists to reconsider their hypotheses regarding the formation and evolution of planets. The planet's discoveries continue to challenge our preconceived notions about our solar system. The magnetic field of the planet is a little strange. It is displaced by around 1/5 of the planet's radius rather than being centered. This anomalous location might be caused by uneven crustal thickness, which could alter the planet's internal heat flow. Scientists discovered elements like sodium, potassium, and sulfur on the surface in 2021. Finding these elements on a planet this near to the sun was unexpected, since normally these elements would vanish rapidly under extreme heat. According to Dr. Patrick Peplowski, these components might have been brought about by asteroids or comets striking the planet after it formed. Another startling observation was water ice in craters near the planet's poles. These areas are sufficiently cool and shaded to prevent ice from melting. Nancy Chabot, MD, was instrumental in this finding. Carbon-based molecules known as organic compounds are also found in the same craters. These might be the same ones that brought life to Earth. This suggests that the planet may have some information on the origins of life in our solar system. That's not all, though. Scientists thought the planet was geologically extinct for a very long period. Nonetheless, indications of recent volcanic activity were found by the Messenger mission. They discovered patches of what appeared to be volcanic vents. This indicates that life is still occurring on the planet. The planet's south pole is another enigma. Its topography is untamed and chaotic, including peaks and valleys the size of Texas. Dr. Thomas Waters thinks that severe quakes, induced by changes in the planet's orbit due of the sun's pull, may have generated this unique topography. Dr. Amir Khan discovered that the planet has a larger solid inner core than Earth and a liquid outer core after analyzing data from the Messenger mission. The peculiar magnetic field might be explained by this unusual structure. There is still much to learn about our solar system, as these findings refute what we previously believed to be true about the formation and evolution of planets. Now, we descend into the planet's core and surface to uncover what surprises they disclose. Secrets under Mercury's surface. The planet's width, which makes up almost half of its core size, is approximately 1,265 miles. Compared to Earth's inner core, which makes up only 20% of the planet's overall core, this is a far bigger amount. It's little, yet its magnetic field is rather strong. Though weaker than Earth's, it is nevertheless quite important. The planet's mantle is far thinner than previously believed under its rocky surface. The mantle of the Earth is just approximately 260 miles deep, according to recent study. This is incredibly thin compared to Earth's mantle, which is roughly 1,800 miles, or 2,900 kilometers, thick. The planet's geological activity and the distribution of heat inside it are both impacted by this thinner mantle. An important discovery regarding the planet's surface was made back in 2012. The shallow depressions known as hollows are proof of historical volcanic activity discovered by the Messenger spacecraft. These were created when some substances escaped into space and evaporated, indicating that the planet may contain more volatile elements than previously thought. However, this wasn't the most unexpected discovery. After examining further Messenger mission data in 2020, researchers found a massive, prehistoric magma reservoir buried under Mercury's crust. This massive lava lake most likely had a significant impact on the formation of the planet's interior structure and surface. Additionally, it could provide an explanation for some of the peculiar surface features, such as the vast, level regions referred to as the northern volcanic plains, which were probably formed early in the planet's history by enormous lava flows. In 2022, a startling discovery was made. Signs of trapped nitrogen below the surface were discovered by the researchers. It is possible that this nitrogen represents remnants of a former atmosphere driven underground by intense heat and solar radiation. This finding begs intriguing concerns regarding possible historical climatic conditions and if the region was ever more habitable. However, the tale is not over yet. Ice that most likely originated from comets or asteroids striking the planet in recent millennia can be found in some of the craters that are shaded from the sun. It's possible that dark objects, maybe organic substances, also came through these holes. These materials offer a rare chance to gain additional insight into the distribution of organic compounds across our solar system. The surface displays several significant distinctions from Earth, including as the lack of plate tectonics, and tells a tale of its lengthy and complicated past. It is contracting as it cools, even in the absence of plate tectonics, leading to many surface fractures and faults. These distinctive qualities contribute to our growing understanding of this intriguing and multifaceted world. Significant fissures reveal the underlying strata when one landmass pushes against another, providing further information about the region's geological history. In 2019, scientists discovered an unexpected discovery: it could still be evolving. Beside the bigger fissures, they discovered grabens, which are tiny, narrow valleys. Grabens are formed as the Earth extends, and the fact that they have just recently appeared indicates that the surface is still changing. Its distinct magnetic field from Earth's is another peculiarity. Its magnetic field might originate from a different source, such as a layer of liquid metal around a solid core that functions like a dynamo, whereas the magnetic field of Earth is produced by the flow of molten iron in its outer core. Additionally, there has been discussion on fissures and openings below the crust that may let the passage of heat and potentially even liquids. Despite the seemingly dead top, some scientists believe that there may be pockets of water far below that are kept from freezing by the residual heat. Considering comparable circumstances on other hostile celestial worlds, such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both of which contain seas beneath their ice surfaces, this theory isn't as crazy as it seems. Therefore, it is not impossible that there could be water beneath the parched surface. An investigation of the core, learning more about these obscure regions, piques our interest and helps us comprehend the continuous mechanisms that shape it. Something else to think about is that this information may also help us understand the geological processes occurring on other planets and moons. Subsequently, it turns into an essential component of the wider picture, enabling us to investigate and gain further insight into the solar system and its historical evolution. But remember, the narrative doesn't finish here. It never ceases to amaze us, and the more we discover, the closer we are to unraveling the secrets of our cosmos. What internal changes have occurred over time? What unusual substances may be present under its surface, and what might these disclose about the origins of our solar system and the formation of planets? These are important topics that highlight the need for more research. Every new discovery we make about the planet's interior helps us comprehend not only this one, but also how all the planets in our solar system form and evolve throughout time. Scientists are eager to see what discoveries may be made on upcoming space missions. Despite being tiny and near the sun, it still has a lot of mysteries to solve. We may learn more about what's within from these secrets. We may discover a great deal about other planets in our solar system and perhaps beyond by looking into these aspects. It could help us understand how planets survive in severe environments around their stars and how they stay stable for billions of years. Every new piece of information that scientists gather and send out via probes has the potential to alter our understanding of space. It is an exceptional location to test our theories about how planets form and evolve because of its intense heat and proximity to the sun. We get more questions as we learn more, which piques our interest and motivates us to investigate it and other planets even more. Despite being one of our nearest space neighbors, there is still a great deal we don't know about it. Regarding its surface, core, and internal processes, we still don't know everything. Researchers believe that by delving further into it, we may uncover secrets about not just its past, but also the origins of other planets, such as Earth. Every new finding may provide insight into the formation and evolution of planets in our solar system as well as in other star systems. It is the ideal location to test our hypotheses about how planets develop and survive because of its severe environment, which includes intense heat, cold, and a thin atmosphere. Researchers are interested in learning how a planet this tiny can survive for billions of years in such close proximity to the sun without perishing. Does it have any unique elements that enable it to withstand these circumstances? Might these substances also exist on planets in other solar systems? Every new expedition there has the potential to alter our perception of the cosmos. We can discover more about its surface, atmosphere, and interior workings with the aid of satellites and probes. Our capacity to investigate technology advances when new tools and technologies are created. Every new mission has the potential to advance our understanding of the cosmos and help us unravel the secrets of this extraordinary planet. Might Mercury provide the means to find extraterrestrial life? For more, please like, comment, and subscribe.